Good afternoon. So thank you for attending. I'm hoping this will have relevance because I've already found myself rehearsing some of the arguments I'll be using here in the conversation we've had over lunch. So at least I have the satisfaction of knowing it's topical for at least some of you. Let us, I just wanted to give a very brief introduction as to why I'm here talking about developer-centered security. So I did many years just as a grunt programmer, so I can say, you know, I've got the t-shirt, I've done it. And then for about 10 further years, I did time as a consultant, which was introducing object-oriented design and eventually this odd thing called agile that some people were inventing over at Caterpillar in the States. And that then became moved into a, well, if we're going to pontificate, we're going to talk about agile, wouldn't it be rather fun to actually start doing it, to see how it would work in a real team with a real software company? And so I set up a software company and we did agile development for 17 years, working with mobile phones, which was an area I knew well. And then that got me in due course into software security, because that turned out to be the thing that was really required in mobile phones in about 2010. Nobody knew how to do it. And so the only way to find out was to start researching it myself. And that became a research post at Lancaster, and I've been there now since 2015. So what's the problem? I imagine for most of my listeners, this sort of list of all of the horrible things that have been happening is totally familiar. T-Mobile, enormous costly attacks, WannaCry, billions of dollars of lost productivity, people dying from hospitals, etc., etc. Heartbleed is one close to my heart because I remember sitting down, doing an all-nighter, fixing and upgrading a system so that it would fix the Heartbleed vulnerability before somebody managed to attack our mobile money system. And of course, the big daddy of them all for senior management, GDPR, the requirement that we actually do a bit of privacy in our software development, or else we end up paying large sums of money, and quite rightly so, probably. And as a result, companies, if not individual developers, are kind of running scared. They have got a big problem. They are aware of the problem, but in many cases, the knowledge of how to actually deal with it is a little bit nebulous. Microsoft manage it. They just said, we will do security, and a huge number of dollars later, there was security in their systems. But for most organizations, it's not as simple as that. And so there's a lot of fear, if not uncertainty and doubt. And we've also got a kind of change in the way everything's happening, which is that we've moved from the kind of perimeter-based security, which is lovely. You can release anything you like because you know that those wonderful people in the security department will be managing the firewalls in such a way that you don't have anything to worry about. That was 5-10 years ago. Nowadays, it looks more like that. We've got collections of things, all of them kind of open or not very far from the actual open internet. We've got systems talking to each other, this what do we call it? Postmodern software, where you actually create the functionality you want by nailing together Gmail and some sort of, you know, the best of breed of some project management tool and something else. I did it recently in a company, fascinating. You can achieve an enormous amounts with very little software. But all of these things mean that the possible role of the security specialist is no longer as the superhero solving everything. That model has gone. It just doesn't work. They are still needed as the, contributing to the security, but unless the development teams themselves are, how do we say, engaged, security is not going to happen. It's just got too complicated. You just can't measure it. You can't, even if you pen test it, you don't know that what you've got is going to be completely okay. And that gives us a possible model for engaging with companies with this problem. We can start thinking of being the people who provide the go-between between the developers, the security experts, and one more, and I'll come to that. So, I promised in the blurb for this that I would talk about us as researchers. And I thought about this a bit, and I thought, well, there are about 3 ways that we can really contribute to supporting, to building on this problem of how do organizations do security? And they are industry analysis, overall views of what's going on in industry. We can provide feedback to individual companies, and there was some discussions at lunch over people here who've done just exactly that. And we can provide solutions, dark trace, whatever, things that, pieces of stuff that go out and become part of the weapons that developers use to improve their security. So in this talk, I'm going to give examples of all of those 3 things from work I've done with people here and elsewhere, and some of the results we've got out of there that might be of interest, or might be just of interest as the sorts of things that you can get from doing research in this way. So let's look at industrial analysis. And the root of all of this is trust. As research teams, we don't have what the English idiom is axe to grind. We can be seen as a safe person to tell. We can keep secrets that you would not dream of giving to your competitors. You can give a researcher information that you couldn't give someone else in the industry. And that also that's really what is behind surveys we do as well. People are prepared to answer a survey saying what security things they're doing to someone who says, oh, I'm from this university and I can prove it, and here's here's all the credentials, and here's the ethics that we have to, the process that we have to fill in. And here's how, and you can be sure that what we're going to get out of this will be a reasonably objective view of what's happening. So people are much more willing to answer, at least I hope they are much more willing to answer what are effectively personal questions to that than maybe to somebody who has more kind of self-interest in the whole world. And the sorts of methods we use for that are largely graphical analysis. What do I mean by that? Charts. Here's the data in a form that you can understand. But for most serious papers, people also ask for some p-values. which after a lot of wrestling, I've realized is actually a Bayesian. It's all about Bayesian probability. It's about the null hypothesis. If I'm completely wrong about that, please tell me, somebody. But that is the way it seems to be working. And the one thing that all of the specialists I have spoken to agree is that you must predict before you go and get the data. So I often see this broken in some of the work I review. So I'm going to leap up and down and say, the one bit of methodology that you've got to get right is make the prediction, then do the analysis, you know. So we've done this with a couple of things recently. There was a survey we did of App Store developers, where we looked at whether people who knew what they were doing were actually doing more security, more software security, more assurance techniques of one sort or another, were they doing more pen testing? And the answer was yes. Well, who's surprised? But we also looked at several other things, including whether needing more security, we were arguing this one over lunch, whether people who need more security actually do more security. The answer is yes, they do. Not a surprise, but something more of a reassurance when you look around, and you can see that, of course, given all these measures of those error bars on it, there's a lot of variation. So there are people who need security and don't seem to be doing very much, but, you know, on average, we're doing well. So that's the sort of information you can get out of a survey. The other thing you can do is be trusted to analyze information that's already around. So in the case of surveys, that's information we've collected for ourselves. In the case of another piece of work we did, we looked at this Bsim model, which has been going for 17 years, I believe. No, it must be more like 15. But anyway, it's been going a longitudinal survey of companies done as a service by quite a large team of people. It's been going on for a long time. The data set is large and interesting and not much analyzed, because it's used mainly by companies who want to tick the box and make sure that they're doing about right, you know. So there was some potential fun stuff to get out of that. And we, again, using this trust, you can be trusted to do something that, you know, that other people, that say other commercial interests certainly wouldn't have been. We got access to that, and we were able to analyze the extent to which activities were found in companies and what was and how they correlated and how they changed over the years, and a variety of other statistics that hadn't been done by the data gatherers. And that was really quite fun. My favorite conclusion was trying a cluster diagram to see which activities tended to be used together. And what we found was, that you seem to get sort of little clusters of things that people were doing together. And in particular, there was one set of things, I'll move on, up here, that seemed to be done by almost everybody. Now, I don't know that anybody else has ever found that, but if you are starting in a big company, you're starting a security, you know, process, if you're starting a security campaign to do to bring in security into your teams, I think you could reasonably say this would be a really good place to start, because it's what lots of people over 17 years, over huge numbers, you know, 500,000 developers are represented here, you know, have done. It might not be spot on correct, but it's certainly more likely to be correct than anything you could come up with sort of with a bit of thought in a relatively short time. So if you're advising somebody where to start as a security program in a reasonably large company, here would be a great place to start. You know, top, I can't remember how many it is, 11, something like that. There are a few other ones that seem to appear together, but when you look at them, you realize what's going on there, that they're things that are related in, you know, people who are using a particular type of architecture or something will need particular sorts of security. But this was a big surprise. And another thing, which was, we were talking at lunch about how you get, you know, how it's quite useful to have a, what do you call it? Security people in each team acting as a satellite for the core security expertise. And to my astonishment, it is absolutely clear that if you want to adopt a large number of activities, what you need is that satellite. There were sort of correlations with the company size and with the number of people in the central security team and something, but this one was by far the best correlation. And I know that I did say earlier that you make the prediction and then do the test, which I didn't do here. And the reason why I can still claim it's valid is because with a probability of 10 to the minus 28, it really doesn't matter. There is no chance that that could be a fluke. So what we've got is, yeah, if you want more activities adopted, have a big satellite. That makes sense? The next one is work in progress. One thing that we can, for me, but some of you it's definitely not, one other thing that we can be trusted to do is to come into a company and provide some sort of objective feedback as to how they are doing or what they can do to improve. That's really a sort of consultancy role. And as developers, we usually do it because we want some sort of data ourselves from the engagement. As researchers, or either that or we just want the money. But you know, that's a difference. That's not research. So we can be trusted to provide feedback. And again, the method can be automating some sort of response or having some sort of process or research method or feedback method that we can bring in and use it to bolster our own knowledge and our own insights, so that it becomes more than just yet another person telling them what to do, and it becomes something they can measure and value for themselves. The particular one that I'm doing was a fun thing that we started recently, which was just seeing if, well, could we do a survey for a team that would tell, you know, give management, the team leads, an idea of what sort of training and improvements and so forth they might need. So we put together a survey, automated it so that it generates a report for each team, it makes it for each team, generates a report for each team, and the report then goes back to the team and the person who commissioned it to, you know, and it says, the following is true about your team. I'm not telling, you know, we're not saying who said what, but these, you know, this team has come back. And again, this is where the trust comes in. We're not saying who said what. You know, whereas we get anonymized data about what various teams are actually doing. So it has benefit there. Does it work? It's difficult to advertise. So all of these things, how do you enlist people? It would be probably by doing much the same sort of talk as I'm doing now, but it's at a commercial conference, and that's been impossible for 2 years, but we're starting doing them again. And working with people like this can be really rather fun. So we're still, this is a long story, but it's something we're doing. And finally, the big one, the solutions. This is, you know, as a software developer myself, I like solutions. I like building things. I like solving problems. As a researcher, I like, in software, I like seeing new things. I like solving problems. And what we're doing here, and this is, I'm choosing this moment to define my developer-centered security, is looking at what you might call a traditional model, where you gave a secure development process to a developer, told them to a development team, told them what to do, said, get on with it, and they got on with it because they were told to. It's a nice scheme and has worked in some big companies. It doesn't work in small companies because the authority of the security people is not enough to get the, you know, to force development to change. So the model that works is the developer-centric one, developer-centered security, where the intervener's job is to help, is to persuade the developers that security is necessary, and they then select the tools and techniques they use according to their particular needs. Developer-centered security. The actual methodology we're using is design-based research. There's several permutations of design-based and research, which are all a bit different. This particular one, the way in which they are similar is that you are both doing in your in the research, you are both designing an artifact of some sort that is your solution, and you are gathering more information about the problem area you're working in. In point of fact, that's the kind of official way of doing it. We found it was more like this. So it looks a bit more like, you know, your problem and your theory making actually fed into the thing you were designing. And the trial actually generated, the trial was what generated the data that tests the hypothesis. And so what you're doing is you're building up a model, a research model of the worlds you are working in at the same time as you're building up the solution that changes that world. Nice and symmetrical, really. Feels like a science fiction story. And I thought I might just lead you through the history of what we did to see something about why I'm talking about this as an iterative process. So as a bit of fun, several years ago, I created a variant of some work that Tavais Rashid and some of his team were doing, which was the app security game, which is a card game in which the developers or whoever's playing pretend to be product managers and decide what security to put into an app. And it works in rounds, that's why it's agile. And for each round or each iteration, bad things happen, attackers come along, and the players find out whether their selected improvements solve the problems. So that was, it was just a bit of fun. I thought people might learn a little from it. I thought, they might enjoy it, which they did. We got about 60 or so people. And one of the 60 or so said, phone me up. Sorry about that. Phone me up a few weeks later and said, could I do that in my own team? And I said, yeah, of course. But why don't I come and do it and we'll teach them a bit more? So that became, okay, yeah, we'll do that. And the bit more that we taught was threat modeling, because that seemed to be something that was missing. I'm using threat modeling, really it should be threat assessment, because I'm not using it in the Microsoft sense of finding defects. That was an unfortunate change in the way that the word was used. So we're talking about finding out who might do bad things and why, which is something that a lot of developers just have not thought about. If you don't ask, it's not that they don't know, they don't have access to the information. It's just unless you actually ask, they don't know. And so we added to that in due course a kind of risk impact assessment. Now, I'd be the first to admit that this is a horrible way of doing risk impact. It's got all sorts of flaws. The one thing I will say is it's a great deal better than not doing it. So in this, you sort, and we use dot voting for this as being as good a way as any. We sorted the various things that might go wrong into how likely they were, risk, and how damaging they were, impact. And then from that, you can say, okay, which ones are we actually interested in? Well, clearly, if there's anything in the top right-hand corner, we better deal with that first. And after that, well, we sort of move out in a southwesterly direction on the chart. So you'd probably at this one, you'd look at the medium impact ones, those ones. And so that way, we encourage the teams to select the things that they actually thought would be a problem and to work on them. This is an example of the 80-20 rule. Does that sound familiar? 80% of your work deals with, 20% of work will solve 80% of the problem in this version. So if you concentrate on 20% of your stuff, of your possible problems, that will solve 80% of your total. You'll notice that since it's developers, if you can see that, probably not. I noticed disgruntled developers was considered extremely unlikely. They were quite a happy team. So I worked with the developers who were doing this just to see how it, mainly coming back to talk to them, mainly to see how they were getting on, whether this had any effect. And we would have regular workshops or Zoom things to just see how things were going. And the first question that they came up with was, here's a list of problems we've identified. We've been looking at OWASP. Here's a list of the problems we've identified using your threats, using your whatever. We know we want to fix all these problems. How do we prioritize them against other demands? Please, Charles, tell me which things should we do first? I looked at it and I thought, I am not the right person to answer that question. The right person to answer that question has a title in the agile world and is called the product owner. So my answer to all their questions was, go ask the product owner. The only person who's allowed to decide what the developers do really is the person who's the product owner who represents the customer and represents sort of everybody else really. The product owner doesn't want something done, you don't do it. So I came across, so there's our product owner. I found this really well represented by someone called Joanna Curiel. I don't know her personally, but I was at the AppSec Europe thing and she was speaking there. And she said it in one line: developers don't fix security issues. Tasks, epics, and stories, all of the agile things, meaning I've allocated time to this, are what fix security. So it's really, all of a sudden I started to realize this is not often, you know, we've been blaming developers. I find it intensely frustrating that at some point even I saw quoted in a paper that Facebook had blamed their developers for their security problems. Yeah, right. You know, like it was the developers who decided to you know, make Facebook open to all sorts of shared data, etc. It wasn't. The problem is the decisions at priority level of, are we going to do this? Are we interested in this particular security threat or not? So they went away and they consulted the product owners. Who's familiar with a Kanban board for software development? Yes, anyone who's been in software recently will be reasonably familiar with this. So in a Kanban board, you move things that Icebox represents things that are not going to be done. They've been put on one side for a bit. At any time, you have a backlog of things that are waiting to be done, a list of things that are in progress in this particular iteration, things that are being tested, and then things that are done. Yippee! You know, those ones are good. We can tick them off. And then sometimes you'll add something like, you know, things that are waiting on something that we just don't have access to at the moment. So I have one of those up on my board to coordinate all the stuff I do personally. Works very well. But what my team were finding here was that things were they were finding lots and lots of security problems, and they were all remaining in the icebox. Nobody needed them fixed. Ouch. All right, let's do another iteration of our intervention. Clearly, it was not enough just to do the risk assessment, just to do the threat analysis, just to do the risk assessment. We need a bit more. And in order to answer what was the bit more, we had to think a bit about why cyber decisions are different. And the perception or the surprise I had was realizing that actually cyber requirements tend to be completely different from almost any other requirement. Things like reliability, functionality, performance, the end users know perfectly well what they are. They can say how much they want of each one. They can define it. They can give it numbers. They can, you know, they may not want to, but they can. And they can agree, and everything is quite clear, and the demands come from the stakeholders and the end users. And then the product owners say, ah, yes, well, we'll compete, you know, we'll decide which ones we're going to do next, and we'll tell the developers which ones they do. How does that look for security? It's the other way around. Security comes from the technical people. And here I'm including security experts with the, you know, with the developers. They're all people who are notionally less powerful than the stakeholders that are being represented. So security is kind of the loser on this. You know, the people wanting security, the people we care about least, they're the people who are employed to do exactly what we say if we're a product owner. You know, oh dear. Typically, security people have got round this by claiming authority, claiming some sort of must, gaining authority maybe from senior management, etc., and enforcing some sort of veto power. That's the usual way around. That works reasonably, but doesn't scale down into small companies where you don't have such people and the veto power wouldn't exist even if you did. So we've got poor orphaned security sitting here being led into the product owners, but actually with nobody sort of, you might call important in the sense of rich, you know, saying, I want this. Ooch. There's a second problem, of course, which is that product owners tend to think in terms of positive-y things, more functionality, better performance, etc. And security problems tend to come in terms of negative things. This bad thing may happen, that bad thing may happen. Ooch. No. So to a product owner, product manager, it's just not, it just does a big thud. And I would comment that to a more senior, you know, to senior management, quite often you say, oh, there's a danger of this happening. And they'll just say, oh, add it to the list, because they're dealing with so many threats that security threats actually aren't necessarily going to impress them very much. So it seemed to me, and I'm gradually seeing this in the industry, that in a sense, you need to do some sort of security jiu-jitsu. We need to change it from being a negative-y thing to thinking, what is the positive way of representing the same thing? I often do compare real life, as it were, familiar security things with cybersecurity. And the familiar thing is, if you have a lock, if you're selling a lock, you don't sell somebody bad could get into your house. Have you ever seen a lock? Well, yes, I mean, you do occasionally see burglars could get into your house. But what they sell is security. What they sell is the positive thing that you can sleep at night, that you're, you know, that your house is safe, safety, that it's a positive thing you are selling, because people pay for positive things. They won't necessarily worry, you know, they won't necessarily do negative things. So how do you make security stuff into something positive? Well, I didn't know the answer. I concluded that we'd probably have to spend a while teaching our development teams all of these jiu-jitsu tricks, etc., etc. But because I had a background in agile, and the XP people have a principle, do the simplest thing that could possibly work, we thought, okay, for the first one, we'll just try saying to the developers, do some security jiu-jitsu now on these things. And so we said, you know, take those vital, take those major threats that you identified. Remember those top 5 in the top right-hand corner of that chart. Take those 4 or 5, think about them, think about what your solutions are likely to be and roughly what the costs are. You know, nothing big, just what sorts of things would you do about them. And also, so that's the cost, also think about how you present solving that problem in a positive way for your organization. Why does somebody want that problem solved? And it worked. People came up with lots of there are a whole range of different positive security things they came up with. My favorite was a company down the road who did websites, and they were finding that there was no real representation of the cost of putting in security when they did quotes for their customers. You know, so something that was incredibly sensitive, like collecting medical data, was just as, you know, was just rated as just the same as a plain vanilla standard website just showing, you know, showing static pages, you know, and that was driving them nuts. They were actually very good at security, but they were finding they were having to do it for free. And after thinking around that challenge, they realized they could offer gold, silver, and bronze security. Gold is expensive, silver less so, bronze less so. And while you can't sell a customer on, I'm sorry, what you've chosen is very worrying, we'll have to charge you more, you could say to the customer, do you want gold, silver, or bronze security? I think you've chosen to collect lots of medical data, lots of personal information. I think we probably need gold security. And they can go back to their senior management and say, well, I wasn't going to say bronze, was I? Look, we'd have been in big trouble. Because we've now got a way of talking about the amount of effort in a way that makes it sound valuable. I love that one. Another good one was a company who, well, there was actually a government organization who were doing something incredibly secure, and I've no idea what it was. But they went away and they thought about it a bit. You know, they knew that they had to do every single security thing. Absolutely, there was no question of leaving anything undone, of not putting in any feature. You know, it absolutely had to be there. They had a horrible, you know, horrible series of threats. So there was no security to sell there. And they thought about it a bit, and they thought, yes, but we don't have to put it all in on day one. Because their big worry is that their customers would just get fed up and cancel the project. So they realized that they could put in the things that absolutely needed to be done at the beginning in the first thing, but leave dotting the I's and crossing the T's and all the expensive stuff that could be done later till some way down the line when the customers would be all fired up by seeing the early deliveries and say, oh yes, keep going, this is looking really good. So for them, it was a timing issue. They could do the, you know, they could defer some of the security work they could do. And they knew, you know, they had some of the best people around sort of advising them. So they knew exactly what they did and how much it would cost, but they could do it. They could decide what order to do it in. So this whole idea of thinking about the time value, the actual value to the people, you know, to the stakeholders, led them to a way of promoting the work they were doing and really giving value to the security work. So we push this. So what we've got now then is 3 workshops. That was the game, the threat assessment, and the what we call the Jiu Jitsu Workshop. And when I look back at it, I realize it's the classic double diamond structure for any set of workshops. So you do a bit of learning, you do a bit of ideation to generate a whole load of threats, you prioritize by risk assessment those threats, you then promote to, you know, to find good reasons to do it, and you collect the various things you must do. And finally, what we did as development teams, working with those developers, we measured whether they were actually improving in some way the security or the ways they talked about security. And it all looked a bit like that. One, dot voting, risk impact, then promotion workshops. So there we've got the artifact that we were talking about, the intervention, the thing that we were trying out. But as you'll have gathered from my talk before, from what I was saying just now, a lot of what we were doing at the time was learning about what we needed to do. We didn't know at the beginning we needed to do promotion. That came later. And we now have versions that you can use face-to-face, versions you can use online. The whole lot can be downloaded for free. It's as a, as a document and as various appropriate files to work with. And that's a year's work summarized to a few dots. So what we found was these are the sizes of the balloons are the amount that every team was using it. The colors show how much they improved as a result of working, as a result of the intervention. And what we found was that a lot of them were using a lot more threat assessment. And in particular, this thing that we've called product negotiation, working with the customers, working with product owners to figure out what was required rather than just thinking that they had to do it all on their own. Most of them improved. Two of them didn't. They were sort of big companies that were already pretty much doing it. Thank you very much. But for the smaller companies, they certainly did.
What's on the x-axis?
These are different companies. So the x-axis, company D, E, F, G, H, I, J, K. So there were, what's that, 8 companies. And these are activities they might have been doing. The first 5 or 6 are pretty standard. The security champion, someone introduced, that was the, collection of people in each team, and so on. I can explain more, but you can read the paper if you want to know the full details. It's fine. So I mentioned 3 opportunities we have. Analysis via surveys, via just using other people's data, collecting data from other people as it's available. Feedback, kind of like where it almost crosses over into consultant, but as researchers, the pay we are taking is in terms of knowledge and shareable knowledge that we can then give to the rest of the world. And solutions, which seem to work well as something developed iteratively. Try it, succeed, fail, try it, succeed, fail. And as you do those iterations, build up a knowledge and a theory of what you are doing to enable you then to make a better solution, and so on and so on. So we're still working on those workshops. We're still working on variants, and that is each time because we learn things as we do the tests on the previous ones. Does that sound sensible? That's it.